Hello and welcome to Mathematics with Simon. I'm Simon. So today we're going to look at the A-level mathematics topic of the sine rule. We're actually re-recording this video because there was a nuance in the first one that wasn't right, so I fixed it. The sine rule says that given I'll point it out when it comes, given a triangle with sides A, B and C and angles opposite them, big A, big B, big C, then we know that sine A over A equals sine B over B equals sine C over C. Very simple and clear. So this allows us to work out a side given any two angles and a side. So let's say we've got the angles A and B, and then the side A, then we can work out the length of the side B. It also allows us to work out an angle given two sides and an angle. So let's say we've got the two sides, little a and little b, and we've got the angle big A, then we can work out the angle big B, although in some cases there'll be two answers for big B. There'll be an acute answer and an obtuse answer, because basically inverse sine, just let's say the inverse sine of 80, so sine 80 equals sine 100 degrees. So in some cases, if you have the inverse sine of sine 80, that can be 80 or 100. So sometimes this is non-unique. That's the point. And this is also interesting because the whole thing's interesting because up until now, sine, cos and tan have only made sense in the context of right-angled triangles, and now we're applying sine and cos to all sorts of triangles. So how does the sine rule work? So you've got a triangle like this. Sine A is h over b, and sine b is h over a. So h equals b times sine a, just multiplying both sides here by b, and then multiply both sides here by a. H equals a sine b. So we make those equal because they're both equal h. B sine a equals a sine b, and then we divide both sides by sine a and sine b, and we get a over sine a equals b over sine b. We can also take the reciprocal of this, sine a over a equals sine b over b. So this allows us to work out a side given two angles and a side. So in this case, we've got the two angles, pi over 4 and pi over 3, and then the side is 5. So we know that sine pi over 4 over a equals sine pi over 3 over 5. So sine pi over 4 is 1 over root 2, and sine pi over 3 is root 3 over 2. So what this allows us to do is multiply both sides by 1 over root 2, and then take the reciprocal of root 3 over 2, that's 2 over root 3. So then a equals 5 times 2 over root 3 times 1 over root 2. If you're playing this double speed or 1.5 speed on YouTube, it's going to seem really fast. I know I'm talking really fast. So a equals 5 times 2 over root 3 times 1 over root 2, which is 10 over root 6, or 10 times root 6 over 6, and then cancel 2 from the top and bottom, 5 times root 6 over 3, which when you calculate it's 4.082. Now is this right? Well, it's about right, because this angle pi over 3 is a bit bigger than this angle pi over 4. The difference is actually pi over 12, but this is a bit bigger than this. I mean, the reason it's pi over 12 is because this is 4 pi over 12 and this is 3 pi over 12, so subtract them, you get pi over 12. So pi over 3 is a bit bigger, which means this side's a bit longer than this, so 4.082 is about right. It's a bit shorter, which is great. And also we can work out an angle given two sides of an angle. So the two sides we have are 2 and then 2 root 3. So we know that sine pi over 3 over 2 root 3 equals sine x over 2. And then what we're going to do is sine pi over 3 is root 3 over 2. We cancel the root 3's. This left-hand side is just a quarter. A quarter equals sine x over 2. Sine x equals a half. And then x is pi over 6. The other thing x could equal would be 5 pi over 6. But because sine 5 pi over 6 is also a half, but that wouldn't work because we've already got pi over 3 up here. So that would make the total sum greater than pi radians, which is not correct for a triangle. So in this case, there is a unique solution. And actually, Andy Robertshaw pointed out in the previous video correctly that you got pi over 6 here, you got pi over 3 here, which means these two together are pi over 2, which means C must be pi over 2, which means this is a right angle triangle, which means it's not drawn to scale, which is fine. There was no claim that it was drawn to scale, but it's just good to have those kind of sense checks, just thinking intelligently, like, okay, these are pi over 2, then this must be pi over 2. So strictly, this is actually a right angle triangle here. I hope you liked the video. I loved making it, even the second time. Please subscribe and hit the notification bell. In fact, I did enjoy making it the second time because maths is about truth, and we've got to get it right. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.